Okay, music's a little loud. Hello, hello. We're getting into coding. Let me pull up my... I think I'm realizing I'm not going to be able to play music while if I'm watching the stream. Yeah, because it's going to turn it off. Okay. Let me go turn on music in the bedroom real quick so I can have something to listen to, and I'll be right back. Okay. I did it. Alright. So this is the free coding camp. As you can see here, I started a while ago and I've made it through a couple. They're not very long. Okay, this unit will teach you about math functions. Okay, a YouTube video to watch.
So what does it mean to be a function? A function means in math and in code that you're taking some input and then doing something to it. And actually there are some functions in code you don't have to take input, but in math we will. So like we were talking about our unknown number being x, the output will be y. So each function we want to take x as the input, and then we're going to say that the output is y. And here we're dealing with all numbers. What am I doing to x? And then outputting y. So you see, we have like solving for x we were doing before, but now we have a second variable. And we still want the idea that just like in the alphabet, x comes before y. In science and in research, we can call x the independent variable because that's what changes first. And then y is the dependent variable because it depends on what x does. So if I want to solve this or do anything to it, then I'm going to plug in a value for x. And I can pick any value. I might start with 0. So I'm going to define it over here. My input x is 0. And then what happens when I plug that in? So that'd be y equals 2 times 0 plus 3.
Mm-hmm.
And you see, I'll just put
So
in 0 in parentheses where I plug in this number because it highlights that that's what I just plugged in, and also the fact that they're next to each other, I'm still multiplying. So when we do this, 2 times 0 is 0 plus 3, then that would be y equals 3, and my output is y. And if you remember, then that's an xy coordinate on the graph. X is 0, y is 3, and I'd be able to plot that point. And I can keep going. What other numbers can I plug in? I'm even just going to keep this. So supposing I have x equals 1. Plug in 1, 2 times 1 is 2, plus 3 is 5, y equals 5. And then we'll plug that in. And I can plug in as many or as few. I don't have to have integers. I tend to do that so you can see the numbers a little bit clearer. But you don't have to worry about doing any other calculations in your head. But if I have this, I can put in whatever numbers I want.
Right.
As many or as few, I can put decimal numbers in there, and we can plot these on the graph, which we'll talk about a little bit later. But this is the essence of a function, that x comes before y. I plug in the x value and then output the y value.
Got it.
So another function notation that a lot of people like is instead of using another variable y, and this connects a lot with the way the code's going to look, we call it f of x, and f for function. So
F for function.
2x plus 3. So if you see these are the same thing. Y equals 2x plus 3, or f of x equals 2x plus 3. This notation, f of x, and that's where we read f of x, f for function. We solve it the same, and this connects a lot more. So with your computer science, so if I have the output called f of x, one of the advantages when we get into writing the code is that in algebra, we tend to just say f for function. But in writing Python or other code, you can actually give your function a name, and it doesn't have to just be f for function. It can be add, divide, calculate the area, something really even a long phrase like that, as long as there's no spaces. So if we have this, and then sometimes let's say if I wanted to plug in a 2, I could write in f of 2. And so again, the usefulness of this notation is because I see what am I already defining as my input, and then I know what am I doing next. I'm going to do 2 times 2 plus 3. 2 times 2 is 4 plus 3 is 7. So f of 2 is 7. So now I know that answer, and when I see that, x is 2, y is 7.
Okay.
And we'll see how this really relates to the code, and how we can write even a little bit more elaborate functions with code, and how we can define the input there. Then we'll look at graphing it. All right, so let's take a look at the code. So with the code and functions, we can do
Hold on. So before we do that, I need to pull up my Why is that here? It should be in here. This is a different website. Can't be this. No. Okay. Let's see what pops up. Where did I save this bitch? It should have been there. These are games. I don't know what this is. Okay. All right. Oops. Okay. So he typed in here x equals 5, y equals 4 times x plus 3 number the function and then print x. What is this? Are those quotations? Why? This is annoying. For x in range 11? It's not tabable. Two tabs? Yeah, we'll do 2 tabs. Okay. Y equals 4. Oh, it's the same thing again. Print x t y. Okay, let's see what he says. Now I gotta read it down.
Similar to what we would be doing by hand,
Being blinded
writing
by
out
the
the math.
sun.
Here I'm just going to define one x value as an example, and here is the function in that y value. Y equals 4 times x plus 3. And see Python syntax, have to make sure we put the times. So I'm just going to plug in that y x value, substitutes in for this x value, so it's 4 times 5 plus 3, and then I'm just going to print out my solution, x, comma, y. So we see that. And before I print that out, so that's one thing, one x value. But I can loop this. So I'm going to print out this line here, which is x, and then I'm going to put tab y.
Okay.
So that's defining my columns here, x and y. And then what I'm going to do is loop through all those values. So for x in range 11, so x is going to go 0 through 10.
Right.
And then I'm going to take that same function, and each time then I'm going to plug in that x value, and solve for y, and I'm going to print out the x, y values. And in this case, again, I'm going to put the tab in between. So this is the essence of what we're doing with a function. Each time I get an x value, plug it in, solve for y, and then I have an xy value, and this is going to print this out as a table. So when I run this, we'll see it'll come out. First of all, we'll have that one solution. You see 523, 5,23, that first solution, and then we have our table, xy, and all of our xy values. If x is 0, y is 3. If x is 1, y is 7, etc. And we also have 523 that shows up on the list too. So that's defining a function. Now, Python has a lot of other functions beyond math you can do things with, and we can still use that same type of Python function definition for our math. Here we can, on this line, define the function. So def.
Hold on.
Function.
I can't see because of the damn sun. Okay, try again. Oh, and I did it up here too. For X range. There's a space here that's not supposed to be here. Alright, let's try again. X is defined. X equals 5. Y equals 4 times X plus 3. Remember the function. Print. Okay, let's try again. Trace back. Hi, Callie. How are you? Trace back. Most recent call cell. X is not defined. X equals 5. So it is defined. How is X not defined? Oh, because I think I capitalized it. X. Is that better? Let's try again. X equals 5. Yeah. The Y is not defined. But it's because I capitalized it. There we go. Okay, try again. Yay, I did it finally! I got it! Boop, boop.
Out of the table. So when I run this, we'll see it'll come out. First of all, we'll have that one solution. You see 523, 5,23, that first solution. And then we have our table, xy, and all of our xy values. If x is 0, y is 3. If x is 1, y is 7, etc. And we also have 523 that shows up on the list too. So that's defining a function. Now, Python has a lot of other functions beyond math you can do things with, and we can still use that same type of Python function definition for our math. Here we can...
Okay, well, I gotta write all this in because I'm practicing, so df... Okay, I gotta stop capitalizing. I'm really working on doing that more. Y equals 4 times X plus 3. Where to put the spaces is the question. Return Y. Print Okay, number next. A loop. Let's see what he says now. I think I got it.
On this line, define the function, so def space, and Python, I can name my function anything, but I'm going to use the classic math notation, f of x, and then here I have a colon, so this is going to define the function. Everything underneath is indented 4 spaces, and I have y equals my 4 times x plus 3, that's the function. And what am I going to do? Then I'll return the y value. So whenever I run this, that'll return the y value. So you see this in use. If I print here, if I print 5, so I already know I want that to be my x value, comma, and then I'm going to call this function right here, f of 5, and it's going to take that and run it through. There we go. Same type of thing. Then we'll define this, and when we run this, it's just going to print that 523. And next we can put this in a loop. I could just take this same loop here, and I'm going to copy this, and I can just take that same loop if I wanted to. And in this case, I'm going to print, because I already have that function defined, I don't need this. And I could really just put that here, f of x.
Wait, what
See?
did he just
So
do?
I could just have right here. I'm going to print, because I already have that, I'm going to copy this, and I can just take that same loop if I wanted to. And in this case, I'm going to print, because I already have that function defined, I don't need this. And I could really just put that here, f of x. You see? So I could just have right here, since I defined that function, x, f of x. And I don't have my headings here, but I think these are imaginations. There we go. So printed that one value, but then in the loop just went through and loops. So these are the ways that we can illustrate a function in code. And what we can do with these functions, is
There we go. Okay, got it. Cool.
almost limitless. You can have a function do anything, and you can name it anything more complex than this. Give it a word. But I wanted to show you the connection with the classic math notation and functions in Python. Whether I actually just call it y equals, that still works as a function, or whether I define it. And next, we're going to look at graphing functions.
Okay. After defining a function in Python, indent each line of the function how many spaces? 4 times. Okay.
So now when we talk about graphing functions, we'll use this equation, y equals 2x plus 3, and I'll use the x and y notation. So we have our input and output, all the different x values and what y values match up. So if you ever come across something like this, you can see that if I plug in both of these x and y, that should make the statement true. And so we have a few of our points here. And then now we're going to see how that matches up with the Cartesian plane, or xy coordinate plane, Cartesian, because René Descartes invented this. So we have 0, 0 at the center, and how much I count for x, positive to the right, negative to the left, and it comes first, like x comes first in the alphabet. Then my y value, positive up, negative down, and my coordinate pair would be my xy. So this 0, 3 would be 0, so I'm not going left or right at all, up to 3, plot the point. Now I don't also need to write this, but I'll show you. So then that would be the point 0, 3. So xy.
Right.
And then 1, 5, so I would go over 1, up 5, plot the point, and then that's 1, 5, 2, 7, plot the point. Now, I just plotted 3 points, but I'll tell you, if you really wanted to try many in-between points, decimals, or other numbers that are in between, you could bet that each of these, whatever, 1 point something, 2 point something, they would all end up being on this line. It's continuous. There's no x value.
Okay, real quick, because I want to answer this. Okay. So anything on the 0 line will have to be on the blue line. This is on the 0. So that will be on the blue line. Okay, go on.
Value that can't go into this. Whatever weird fraction or decimal, mixed number, anything. So all the numbers would be on this line. So with this type of function, we're going to call it linear, and we'll get into other types of functions. But that's where we plot a few points, and then we want to look at these patterns. What type of graph does this end up looking like? So what we're going to do now is look at, in the Python code, how to create a graph and plot points.
Yay.
Make a basic line graph. We're going to import.
Real quick, before we do that, I just wanted to see. I think this is the stuff that he's about to teach us right here. So I'm going to move that here so I can copy that.
This library, that plot, that pyplot, and that's a lot. So we can import this as PLT. So I can reference this whole library as PLT from here on out. And here's what we're going to do.
Import.
The first line is, these are standard variables that we use, fig for figure, the axis. So these two variables, and that equals plt.subplots. And then that sets this up, and we'll do plt.show. There you go, import, set this up, and then show. And then that gives a basic graph. These are all the defaults, nothing else going on there. And we have this set up. So we're going to build upon that. Now let's define the dimensions here. Notice that was all just the first quadrant, everything's positive, and these are standard variables that we use, fig for figure, the axis.
But this doesn't look like this. This is the same, but I don't see. Okay, and then here's fig. Okay, so this is the main thing that he's talking about here. We're gonna do that. And then he wants in this. Copy. Okay. Coolio. That's exactly what he was talking about. That's exactly what needed to pop up. All right.
So these two variables, and that equals plt.subplots. And then that sets this up, and we'll do plt.show. There you go, import, set this up, and then show. And then it gives a basic graph. These are all defaults, nothing else going on there.
Default graph.
We have this set up. So we're going to build upon that. Now let's define the dimensions here. Notice that was all just the first quadrant, everything's positive,
Right.
1. So again, import that plot, library, plot. We set the same two first lines, but now let's take a look at these dimensions. Now I have that PLT, so it's plt.axis, and I'm going to set this axis. All right, and it gives you the range of x values and y values. I'm going to show that away in a second, but you can do this all in one line. Here's the dimensions, and now when we show it,
Hold on. Because what I need to add in is some typing. Then underneath this, he says number of dimensions. But this is God damn it. This is getting annoying. I need to have a light and I have the setup, but I just don't want to adjust right now. Okay. Anyways. This is supposed to be axes. 10, 10, negative 10, 10. Okay. Oh, and then is there like a problem here? Thank you. That was fucking dumb. This is the show thing. Okay.
I want it to go from negative 10, we see across the bottom of the x-axis, negative 10 up to 10, 0 in the middle, and on the y-axis, negative 10 up to 10, 0 in the middle. That's great, but
Wait, what's wrong? I did the negative 10, 10, negative 10, 10. PLT dot axes. Try again. Thank you. Thank you.
I have no lines, I have no axis, and not the clearest. So, first of all, here's a better way to set the dimensions. Is I'll define them right at the beginning as variables, x min, x max, y min, y max. And that way, all right, I want it 10 in every direction, and I can set them here. Easy to see it and change it if I want to.
Is that this? Yeah. What is different here? Copy this. Post that there. And it looks like the only thing I'm missing is the PLT dot show. Okay.
And now when I do all this is really what I'm doing when I set the axis size. X min, X max, Y min, Y max. That's really the argument that it's taking. And it becomes a lot clearer when we set it up like this. So then I have this, and
So these are the
I
same.
can set this, and then if I wanted to, I say, oh, for this one, this Y value goes really a lot higher, so maybe I want that Y maximum
Okay,
to be
this
20
looks like math.
instead of 10. And then when I run it. Now, notice the size of this still looks the same, but it adjusted accordingly, and on my Y-axis it goes up to 20. And on my X-axis negative 10 to 10. So, let's display axis lines here. If I have my dimensions defined, and now, when I plot the axis, well, that's the one we already did here, the window size, but I'm going to just plot them as lines. So, this line here, I have x min, x max as my array of x values. See, notice it's plt.plot. And I have my array of x values, and then my array of y values. And the default is to make this a line. So it won't just plot two x values and two y values. It'll draw the line from x min 0 to x max 0. And this b in quotes makes it blue. So we're going to do the same thing with the y. plt.plot, and my x values are going to be 0 at 0 y min, 0 y max, and then again, make that a blue y-axis. Just blue. And there we go. So now we have this that will give us our xy axis.
Right.
So from everything we do, now we have an axis, we have a point of reference.
Okay.
So
this
everything
is the
that we plot is
basic.
going to start with this now. Define dimensions, set all this up. We might not even need to change any of this. And that's going to give us our graph with an xy axis. All right, so how do we plot one point? So we see the axis, the default is a line. And I made it blue, B in quotes. So how do I plot a point? Well, I make this line here. I have an array of one value, which is 5 for the x value, one value, which is 4 for the y value, and then the R makes it red, and the 0 makes it a circle. Actually, that's O. So there's some other options you can do. You can do a dash, you can do a different symbol.
Okay, so this, he's saying pit, plot, and then 5, 4, and row. Okay, go on.
But for right now, I'm going to make this a red circle. And that's how we make that here, if I have these two. And so when I run this, it'll still plot those as an axis, and then we'll do 5, 4, and then that's going to be a red dot. Right. So
not exactly. Pit plot 5, 4. Pit is not defined. Oh, it's PL. There we go. Okay.
if I wanted to plot multiple, now connecting with what we were doing with the functions, here I'm going to set up my graph, and here in my range, I'm going to have the range from 10. So I'm going to go from this value, my y value, y equals 0.5x plus 1. And in this case, instead of making it a table, I'm going to do plot, plt.plot, and I'm going to plot that xy value as a dot. So this range, and I'm going to plot these xy values. And again, that's the essence of graphing a function. I have all these different values,
Right.
and when I plot all these points, I'm going to see this nice pattern emerge, that this all lines up. And I'll tell you, if I plotted points that were in between, whatever x values there would be,
Yeah.
they would also line up. That's why it's a linear function. The graph of it's going to be a straight line. And then every point on this line, every xy value, if I plug in this function, it's going to work. So my loop to graph a function. And here then we'll create a loop to do the function and the table. So like we were doing before, I'm going to build upon this basic graph.
Okay, hold on. Did this. He builds upon it quite a bit into this one. Because it goes from this, right, and he's saying build upon it, and the build upon it is a print. We'll just type it in. Print x. Oops. / t. Y. Right. And here, where print x / t y.
Graph that I have, I'm going to print the x tab y for the heading of the table, and then in my loop, I'll use the same function here. I'm going to plot the point, and I'm going to add it to the table.
Got it.
And all of these, it actually won't plot all. It'll kind of save these points, and it won't plot them all. It's really just going to add them all to the table and display the table, because it really doesn't show the graph until the last thing outside the loop here is going to be plt.show. When you have graphs, I think Python just likes to have that plt.show last. So do your other stuff first, and then show the graph. So then we have this, and we have our table of y values. Notice if I just put one number in the range, it'll do 0 to that number, but I can have -5, 10, or I could even just go back to those original values that I defined up here and make this x min, x max. You see? and then, but you know, you can put any two numbers in here, and it'll do the range between there. And you see, it just abruptly starts here and abruptly ends here. But I could change that to make this x min, and I can make this x max. But remember, I want to graph that last point, so I'll do x.
Okay. So print for, oh, so the range, so he's saying you can change it to anything, but what he's gonna do is x min and x max.
X max plus 1. And I can have that range. And now it'll give the full table of values, and it'll graph the full dimensions. So there we go. We see what we can do with a function. I have whatever math function I have, plug in different values and see the results. See the numerical output, see the graphing output.
Okay.
And now we see the connection of graph, the table, and the functions.
Yeah. Okay. Which of the following would be put on a blue line? Well, I guess one thing we could do real quick, just to make sure, because I kind of just like, right, we'll put them in here. Okay, plot that point. Just give me a second here, because I'm a learning, okay? Ooh, we're coming to the end of our coding session. I'm gonna move on here shortly. Okay, let me see. I just want to finish this one at least. Let's see if I can figure this out. Okay, so if we're gonna put it in here, wouldn't we want to put it like that? So we'll do the one that I think. I think that's it. Just so I can see another one. Oh, wait. I did the wrong one. Hold on. Let me just make sure. Okay, yeah. Which is this one, which I accidentally just did when I was trying to do this one, which I thought it would be. Let's see. But it's not. Okay. And this one, 0, 0, but you get the 10 back. And it's B negative. What is this one? Ooh. Okay, let's see what this one looks like. This one. Oh, I was right. I was correct. Yay! Oh. Okay, so this is where we'll start tomorrow. So we will start here on functions and graphs. We'll start how long is this? 14 minutes, yeah. So that's that. I also was gonna look just at these really quick. I'm really expecting them to explain this to me because I don't know. I'm just gonna file, save as a copy in Drive. Thank you, thank you, thank you, thank you, thank you, thank you. Okay. Thank you so much today for joining me while I was coding and practicing. I hope maybe you learned something or found something useful that you can use to help yourself learn to code if that's something you're interested in. And let's see here. Don't forget to like, share, and subscribe. And I'll see you guys next time. Bye. Okay, guys. I'm not actually going to get off the stream, but I need to end and reset up and come back. So we can do some other stuff. So we're going to change it to decoration time. Decorations. Okay. And I'm going to end and be back.